Most people believe one very simple thing about homes. If a house feels cold, you turn the heating up. If it still feels cold, you need stronger heating, a bigger boiler, a better heater, more power. That idea sounds so normal that nobody questions it. Cold house, more heat. That's how we've been taught to think. But here's the strange part. If you actually look around, you'll notice something that doesn't make sense. Some houses stay warm even when the heating is barely on. Other houses feel cold no matter how much energy you throw at them. Same city, same weather, sometimes even the same heating system, yet one home feels comfortable, calm, easy to live in. The other one feels like it's always fighting the cold. That's the first crack in the story. Because if heating power was the real answer, this shouldn't happen. More energy should always mean more warmth, but clearly it doesn't. And that's where the intuition breaks. Think about how we talk about heating. We talk about it like it's a weapon, as if warmth is something you push into a house. Turn it on, turn it up, fight the cold. But warmth doesn't really work that way. A house is not a cup you pour heat into. It's more like a bucket with holes. You can keep pouring water, but if it keeps leaking out, the problem isn't how much water you add, it's the holes. Most homes that feel cold are not lacking heat. They're losing it. Quietly, constantly, every second. Here's the uncomfortable truth. Heating systems rarely fail at their job. Buildings do. We blame the heater because it's visible. We can turn a dial, we can hear it working, we can see the bill. But the real problem is usually invisible. It's in the walls you never think about, the windows you assume are good enough, the corners you avoid touching in winter. You don't notice heat leaving a house. You only notice the feeling it leaves behind. Cold floors, chilly air near the window, that strange discomfort where the room is warm, but you still don't feel comfortable. That feeling is not in your head. It's physics quietly doing its thing. This is why the idea of more heating equals warmer homes is so misleading, because heating doesn't create comfort on its own. It only replaces what the building loses. If a house loses heat slowly, you barely need to replace anything. If a house loses heat fast, you can keep pouring energy into it forever and still feel cold. That's why some homes stay warm with surprisingly little energy. Not because they're fancy, not because they're expensive, not because they use some magical technology, but because they don't waste what they already have. Let me put it another way. Two people wear jackets in winter. One is thin but zipped up, sealed tight. The other is thick, heavy, and expensive, but full of gaps and openings. Who feels warmer? Not the one with more material, the one that doesn't let heat escape. Homes work the same way. A warm home is not always the one with the strongest heating. It's the one that holds on to warmth. That idea sounds obvious once you hear it, but most people never think about houses this way, because nobody sells homes by saying, this one leaks less heat. They sell size, they sell style, they sell new appliances and shiny finishes. Heat loss doesn't look good in a brochure. This misunderstanding leads to a very common frustration. People move into a new place, they do everything right. They turn the heating on, they pay the bills, they follow the rules. And still, the house feels cold. Not freezing, just uncomfortable. Always a bit drafty, always a bit uneven. Warm in one spot, cold in another. So they blame themselves. Maybe I'm sensitive to cold. Maybe this climate is just harsh. Maybe heating is expensive everywhere. But then they visit a friend or a relative or an older building across town, and suddenly it's different. The heating is lower. The space feels calmer.
The warmth feels steady, not forced. That moment is important because it proves something. Comfort is not only about energy input, it's about how a building behaves. Here's the key idea to hold on to. Warm homes don't fight the cold. They avoid losing heat in the first place. That's it. That single shift in thinking changes everything. Once you see homes this way, you stop asking, how strong is the heating? You start asking, where is the heat going? And that question leads to very different answers. So when you hear that some houses stay warm with less energy, don't imagine luxury, imagine restraint. Imagine a building that doesn't let heat escape easily, a space that doesn't constantly leak comfort into the outside air. That's not magic, that's not luck, that's design, sometimes intentional, sometimes accidental. And once you understand that, you'll never look at heating bills or cold rooms or energy-efficient homes the same way again. Because the real secret isn't how much heat you add, it's how much you stop losing.
Once you accept one simple idea, that heating doesn't magically make a home warm, the next question becomes unavoidable. If heating isn't the main difference, then what is? The answer is uncomfortable because it points away from machines and toward the building itself. The real difference between warm homes and cold ones is not how much heat they produce, it's how much heat they lose. And most of that loss happens quietly, in ways people rarely notice until they start paying attention. Heat doesn't disappear all at once. It doesn't rush out the door in a dramatic way. It leaks, slowly, constantly, from places you don't think about. You don't feel the house is cold. You feel cold near certain things, near a window, near an outside wall, near the floor, near a corner of the room. That's already a clue. Because if heating was the problem, the cold would feel even everywhere, but it never does. Think about where you feel cold most often. Almost nobody says, the middle of my living room is freezing. They say, it's cold near the window. The floor feels icy. This corner is always chilly. I feel a draft even though everything is closed. Those are not heating problems. Those are escape routes. That's where heat leaves the building. Windows are the most obvious one. You don't need technical knowledge to understand this. Glass is not great at holding heat, and frames are full of joints and seals. Even a window that looks perfectly fine can quietly leak warmth all day long. That's why standing next to a window in winter often feels uncomfortable, even when the room temperature says it's warm enough. Your body feels what the thermostat doesn't. Then there are walls. Not all walls behave the same way. Two walls can look identical, feel solid, and still perform very differently. Some walls slowly absorb heat and give nothing back. Others hold warmth surprisingly well. You don't notice this in summer, but in winter, your body notices immediately. That's why some rooms feel heavy and cold, while others feel calm and stable. Again, not a heating issue, a heat loss issue. The floor is another one people underestimate. If the ground below you is cold, your home is constantly feeding it heat. You don't see it happening. You just feel tired of being cold from the feet up. That's why rugs suddenly feel like comfort, even though they don't produce any heat. They simply slow down the loss. And then there are the invisible troublemakers: corners, edges, junctions, places where walls meet floors, where ceilings meet outside walls. These spots lose heat faster than flat surfaces, even in well-heated homes. You feel it when you walk past them or when you sit near them for too long. Most people never connect that discomfort to the shape of the building itself.
but the shape matters a lot. This is why two homes with the same heating system can feel completely different. One is constantly leaking warmth through dozens of small exits. The other holds on to what it has. Heating just fills the gap. In one case, the gap is small. In the other, it's endless. Here's something that surprises many people. A home can technically be warm, but still feel uncomfortable. The air temperature might be fine, the heating might be working, the bill might be high, and yet something feels off. That's because comfort is not just air temperature, it's about balance. When walls, floors, and windows are cold, your body keeps losing heat to them. You feel chilled, even though the air says you shouldn't. That's why turning the heating up often doesn't solve the problem. It just increases the difference. More heat in the air, more loss through the building. This leads to a frustrating cycle. The house feels cold, you turn the heating up, the bill goes up, the comfort barely improves, so you turn it up again, and again, and again. Eventually, you stop trusting the idea that homes can feel warm without effort. You accept discomfort as normal. But it's not normal, it's just common. Homes that stay warm with less energy don't do anything dramatic. They don't fight winter. They simply slow it down. They don't give heat easy ways out. No strong drafts, no icy surfaces stealing warmth from your body, no constant imbalance. The heating works quietly in the background instead of struggling non-stop. And once you see this, you start noticing small things. Why one room feels calmer than another. Why some spaces feel tiring to sit in. Why standing near certain walls feels wrong. These are not emotional reactions. They are physical responses to how a building handles heat. So when people ask, "How much heating do I need?" they're often asking the wrong question. The better question is, how fast does this house lose heat? Because once you understand that, everything else makes sense. Why some homes stay warm with less energy, why others never feel comfortable no matter the cost. Heating doesn't create warmth on its own, it only replaces what escapes. And the homes that feel truly warm are simply the ones that don't let warmth run away so easily.
They look similar, but they don't behave the same. This is where things get confusing for most people. They look at two homes and honestly can't see much difference. Same size, same layout, same city. Sometimes even built around the same time. On paper, they should feel the same, but they don't. One feels calm and easy to live in. The other always feels a bit off. Not freezing, just never quite comfortable. That difference rarely shows up in photos or floor plans because it lives in places people don't look at. We're used to judging homes by what we can see. Big windows, open spaces, modern finishes. But warmth doesn't care about appearances. It cares about details. And the most important details are usually the least visible ones. Take layout, for example. Two homes can have the same floor area but behave very differently. One is compact. Rooms are close together. The shape is simple. The other is stretched out. Long corridors, many corners, more outside walls. They feel similar on paper, but one loses heat much faster. Every extra corner, every extra surface touching the outside is another place for warmth to escape. You don't notice this until winter. Then your body notices immediately. Now think about windows again. Not just how many there are, but where they are. A room with windows on multiple sides might look bright and beautiful, but in cold weather, that brightness comes at a cost. More glass means more heat loss. more frames, more joints, more places for cold to sneak in. That doesn't make the home bad. It just means it behaves differently. And most people are never told that. Then there are the places where buildings connect. Walls meeting floors, walls meeting ceilings, inside corners, outside corners. These spots lose heat faster than flat surfaces. They're small, but they matter. You don't walk into a room and think, ah, yes, a thermal bridge. You just feel that one chair is always colder than the others, that one wall is never pleasant to sit near, that one corner somehow drains your energy. That's not imagination, that's physics in an awkward place. This is why comfort often feels uneven. One side of the room is fine, the other side feels wrong. One bedroom is easy to heat, another is always cold. Same heating, same thermostat, different behavior. Because buildings are not uniform objects, they're collections of weak points, and warmth escapes through the weakest ones first. Another detail people underestimate is how tightly a home is closed. Not in theory, in reality. A door that doesn't seal well, a window that looks closed but isn't quite. Tiny gaps don't look important, but cold air doesn't need a big opening. It just needs time, and winter has plenty of that. This is why drafts are so exhausting. They don't always make a room cold, they make it uncomfortable. Your body keeps reacting even when you don't consciously notice why. Here's the part most people don't expect. Two buildings can follow the same rules, meet the same standards, and still perform very differently. Because standards define minimums, and minimums leave a lot of room for variation. Small decisions add up. A slightly different window detail, a slightly different wall connection, a slightly different layout choice. None of these matter much on their own. Together, they decide whether a home feels calm or tiring. That's why people are often shocked when they move into a new place. They did everything right. They checked the size, the location, the heating system, and still something feels wrong. Not broken, just disappointing. The house isn't failing dramatically, it's leaking quietly. Once you understand this, you stop asking why one home is better than another. You start asking where the weak points are. Where does the heat leave first? Where does comfort disappear? Those answers are rarely obvious. They hide in shapes, connections, and decisions made long before anyone moved in. This is why similar homes often feel completely different in winter. Not because one has better heating, but because one makes warmth work harder than the other. And the more a building fights itself, the more energy it needs just to feel normal.
Why older houses sometimes use less energy. This part often surprises people, because we're used to hearing the opposite story. New homes are supposed to be efficient. Old homes are supposed to be wasteful. That's the common narrative. And sometimes that's true, but not always. In real life, many people have had this strange experience. They move from an older home into a newer, more modern one. The new place looks better, feels cleaner, has newer systems, and yet the heating bill goes up. The house feels colder, less stable, harder to keep comfortable. That doesn't mean old houses are better. It means something else is going on. Older houses didn't save energy on purpose. They didn't follow modern efficiency rules. They weren't designed with climate targets in mind. But they did have one thing that many modern homes quietly lost: simplicity. Older buildings were usually simpler in shape, fewer corners, shorter layouts, less surface exposed to the outside. They weren't stretched out for visual impact. They were compact because that was practical. And compact buildings lose heat more slowly. Not because they're smarter, but because there's less opportunity for heat to escape. Less outside wall, less roof per room, less complexity. Heat likes simple shapes. Rooms were smaller too. That matters more than people think. Smaller rooms are easier to keep comfortable. They warm up faster. They feel more stable. In many older homes, there wasn't a lot of open space to waste heat in. Warmth stayed closer to people, not because someone planned it that way, but because building large open spaces was expensive and impractical at the time. Windows were another big difference. Older homes usually had smaller windows, not because architects hated light, but because large glass areas were risky. Glass was expensive, sealing was difficult, heat loss was obvious, so openings were cautious. Less glass means less heat loss. Again, not genius, just caution. Then there's construction itself. Older buildings used heavy materials, thick masonry, solid walls, dense floors. These materials don't insulate well by modern standards, but they do something else. They slow things down. They absorb heat and release it gradually. They don't react instantly to temperature changes. That creates a sense of stability. The house doesn't warm up quickly, but it also doesn't cool down quickly. Comfort feels steadier. This is why some older homes feel calmer in winter. Not necessarily warmer, but less demanding. The heating doesn't need to chase constant losses. The temperature doesn't swing as wildly. The house feels like it's cooperating, not fighting back. Now here's the important part. This does not mean old houses are efficient. Many lose huge amounts of energy. Many have terrible insulation. Many are expensive to heat. But some of them accidentally avoid the worst problems modern homes introduce. They don't have endless corners. They don't have massive glass walls. They don't stretch comfort thin across huge open spaces. They're imperfect, but predictable. Modern homes aim for performance on paper. Older homes often perform better in reality, because reality cares about behavior, not labels. A house that's simple, compact, and stable can feel comfortable with surprisingly little energy, even if it fails every modern efficiency checklist. That's the real lesson here. It's not about old versus new. It's about complexity versus restraint. New buildings can be excellent, better than anything built before, but only if they respect the same principles older buildings followed by necessity. Keep shapes simple. Limit unnecessary exposure. Don't create weak points everywhere. Comfort doesn't come from technology alone. It comes from cooperation between the building and the climate. So when people say old houses were built better, that's not quite right. They were built simpler. And sometimes simple leaks less.
After everything we've talked about, it's tempting to start making a checklist. Better windows, better walls, better systems. But that's not the real pattern. When you step back and look at homes that truly stay warm with less energy, you notice something simpler. They all do one thing well. They reduce heat movement. That's it. Not in a dramatic way, not with complicated tricks. They just slow things down. Efficient homes don't chase warmth. They don't rely on strong heating to constantly correct mistakes. They don't treat energy like something disposable. They treat heat as something worth keeping. These homes are quiet, not just in sound, but in behavior. No constant drafts, no cold surfaces stealing warmth from your body, no sharp temperature swings. The heating doesn't need to fight, it just maintains.
This is why efficiency often feels boring. There's no big moment, no sudden blast of warm air that makes you feel like something impressive is happening. Instead, the house just feels normal, comfortable without effort. And that's the highest form of efficiency. In truly efficient homes, nothing is working overtime. The walls aren't constantly losing heat, the windows aren't acting like open doors, the shape of the building isn't creating endless weak points. Everything is aligned toward the same goal. Don't let warmth escape faster than necessary. This is also why efficiency is hard to sell. You can't easily show it. You can't take a photo of less heat movement. You feel it only over time, in lower bills, in steady comfort, in rooms that don't demand attention. It's also why efficiency is often misunderstood. People think it's about technology, smarter systems, newer equipment, more control. Those things can help, but they don't fix a building that loses heat too easily. Technology reacts, design decides. When a home is designed to hold heat, the heating system becomes almost secondary. It doesn't need to be powerful. It doesn't need to be clever. It just fills small gaps instead of chasing large losses. That's why some homes stay warm even when energy prices rise. They're not immune to cold, they're just not wasteful. This is the quiet truth behind efficient buildings. They don't impress you at first glance. They impress you in January, at night, when the weather turns bad. That's when you realize how little effort it takes to stay comfortable. So when we talk about homes that stay warm with less energy, we're not really talking about efficiency ratings. We're talking about behavior. How the building treats heat, how fast it lets comfort leave. Everything else is a detail. And once you understand that, the question changes. It's no longer, how much heating does this house need? It becomes, how much heat does this house waste? That single shift explains almost everything.
When energy was cheap, none of this felt urgent. If a house leaked heat, you turned the heating up. If the bill went up, you complained and paid it. That worked for a long time. But it doesn't work as well anymore. Heating is getting more expensive, weather is getting less predictable, and comfort is becoming something people worry about, not take for granted. In that world, the old logic starts to break. Adding more energy is no longer the easiest answer. So here's the question most people never ask until it's too late. Do we keep fixing cold homes by pouring more energy into them, or do we start fixing the homes themselves? Because one of these choices gets more expensive every year. The other one gets more valuable over time. A building that leaks heat will always need help, no matter how smart the system, no matter how powerful the heater. A building that holds warmth asks for very little. It doesn't demand attention, it doesn't fight the climate, it simply behaves better. This isn't about old versus new, or rich versus cheap, or technology versus tradition. It's about priorities. Do we design homes that constantly need to be corrected, or homes that quietly work with us? The difference doesn't show up on the first day. It shows up over winters, over bills, over years of living in the same space. That's when you realize what kind of building you're really in. So next time you feel cold at home, don't just reach for the thermostat. Pause for a moment and ask a different question. Is this house asking for more energy, or is it quietly wasting the energy it already has? That question doesn't have a simple answer, but once you start asking it, you'll never look at homes or heating the same way again.